A secant line is the line drawn between 2 points on a graph. The slope of the secant line tells you the average rate of change from one x value to the other. The difference quotient is a formula to find the slope of the secant line. The difference quotient tells you the average rate of change between 2 points. The difference quotient is f of x plus h minus f of x all over h. X is my initial starting place, the x value at my first coordinate point, and h is the difference between these two x values. Side note, a tangent line is the line drawn that touches the graph in exactly 1 point. The slope of the tangent line tells you the instantaneous rate of change, and in calculus, you will use the difference quotient to find the instantaneous rate of change. You'll substitute in a 0 for the h value. That's also called the derivative. Anyhow, we're just going to stick with the basic difference quotient here, and let's do 3 examples. Find the difference quotient for y equals 4x plus 1. I like to start by first figuring out what my f of x plus h value is. So f of x plus h. Instead of an x value, if I had written this with function notation, I would have said f of x equals 4x plus 1. So instead of this x value, now I have an x plus h. So everywhere you see an x in the original equation, you need to replace with the parentheses x plus h. I don't like parentheses, and you shouldn't have parentheses in these types of problems, so distribute to get rid of your parentheses. Okay, now that we know what f of x plus h is, let's figure out what our difference quotient is. The difference quotient is that f of x plus h value that we just figured out minus each piece of the original equation. Minus each piece, each term of the original equation. So subtract the 4x and subtract the 1. All over h. So take the f of x plus h value that we just figured out, subtract each piece of the original equation, and write it over h. Now all we're doing is simplifying. What that really means is let's combine like terms and then factor and cancel. When you simplify in my class, I like you to distribute and combine like terms. And then I also, if you have a fraction, want you to factor and cancel. So that's what we're doing here. We're distributing and combining like terms on the top in the numerator, and then factoring and canceling because we have a fraction. So if I combine like terms on the top, I have a 4x and I have another x piece here. 4x plus negative 4x happens to be 0. All right, I have a 4h, that's the only h piece on top. I have a 1 and a negative 1. Those are whole numbers. I can add them together, and they happen to add to 0. So there's nothing left on top. Just have an h on the bottom now. You don't have to factor this actually because it's a monomial on top. There's only one term. So all I have to worry about is canceling my h's, and there's my answer. That one's kind of boring. So let's do one that has a little more going on. Let's determine the difference quotient for f of x equals x squared minus 3x plus 1. I like to start by figuring out what f of x plus h is. So instead of an x here, I have an x plus h. Everywhere you see an x in the original equation, you have to replace with an x plus h. Let's simplify that. So remember, simplify means to distribute and combine like terms. You cannot just distribute that squared at the beginning. That's not how squared powers exponents work. Remember, you have to actually write this out as x plus h times x plus h, and now you distribute or FOIL it all out. So distribute your x, distribute your h, and now distribute your negative 3. Combine like terms. It may not look like it, but I do have like terms here. They're not written in the same order, but they both have one x and one h. So I have two pieces that have one x and one h. Okay, difference quotient. Finally, we have f of x plus h simplified. Let's do the difference quotient. So take that f of x plus h, subtract each piece of the original equation. So subtract the x squared, subtract the negative 3x, that makes it a positive, and subtract the 1. Then divide by h. Now all we're doing is simplifying. So we already distributed, let's combine like terms, and then because we have a fraction, we'll factor and cancel. I have two x squared pieces. If I add those together, they add to 0. This is the only xh piece. This is the only h squared piece. I have two x pieces. If I add those together, they add up to 0. This is the only h piece. I have two constant whole numbers. If I add them together, they add up to 0. So notice that everything in the original equation ends up canceling out with something in the f of x plus h. That is why we subtracted. Everything in f of x plus h cancels out. Okay, we have a fraction, so that means we need to factor and cancel. The most basic way to factor something is to say, hey, what do they have in common? Do they all three on top have one thing in common that I can divide out front? And notice they all have an h. If I divide or pull that h out, I can rewrite it like this, and now the h on top will cancel with the h on bottom. If you had a term up here that didn't have an h in it, that means you messed up. You should always be able to pull an h out of every single piece. If that doesn't work, then you've messed up somewhere. You cannot just cancel these two h's, remember, because this one has other stuff added to it. And this is my final answer. This is my difference quotient. Let's do one that is similarly tricky because you have a 6x squared plus 7. I'm going to start like I have before, where I like to figure out what f of x plus h is first. All right, so let's FOIL out, or let's write out x squared as x plus h times x plus h. We need to distribute our x, distribute our h, and now combine like terms, and now distribute the 6. So make sure you deal with the squared piece before you multiply by the 6. It's really easy to get lost here and just miswrite something. So be careful when you're writing everything. And I know it's a lot of writing. Now, let's find our difference quotient. So we're going to do that f of x plus h, subtract each piece of the original function, all over h. And now we're simplifying. Combine like terms. Every term in the original equation should cancel out, and everything that I'm left with in the numerator has an h in it. So I can factor out the h, cancel, and this is my final answer. Notice that if I really wanted to factor this numerator, I technically could have pulled out a 6h. The h's still cancel. And you can say this is your final answer, or if you distributed the 6, you would also have that. Either way, I'll accept both answers.